Hello, and welcome back to another video lecture on basic algebra. In this video, we're going to be talking about rewriting formulas. So often, we rewrite formulas to solve for specific variables. So let's look at a few of the formulas that we're going to be working with in this video. So we have here the Pythagorean theorem states a squared plus b squared equals c squared. This formula tells us the relationship between the hypotenuse and the legs of a right triangle. P equals 2L plus 2W is the formula for the perimeter of a rectangle with length L and width W. I equals PRT is actually a simple interest formula where I is the interest that you're paying, P is the principal amount of what the interest is being added onto, R is the rate as a decimal, and T is time, usually in months or years, depending on the way that this interest is being measured or calculated. Here we have x equals vt. This is a very basic physics formula. It says the distance is equal to the speed that you're going times the time. Most people are very familiar about this, considering a lot of people drive. You consider how fast you're driving times the time that you've been driving for, and that tells you how far you've gone. Up here we have S equals 4 pi r squared. S is the surface area of a sphere with a radius of r. Here we have an equation used in electronics, and it's 1 over r equals 1 over r1 plus 1 over r2. This is used when you have two resistors in parallel, resistor 1 and resistor 2, and the total resistance is related to these two resistors with this formula. Here we have ax plus by equals c. This is the general form of a linear equation of two variables. Here we have f equals 9 over 5 c plus 32 degrees. This is the relationship between Fahrenheit and degrees Celsius. Now we're going to work with each of these formulas and solve for some specific variable, and I'll show you how that works. So first, let's look at our a squared plus b squared equals c squared. So here we're going to solve for c in terms of a and b. Well, that's actually very simple, considering we already have c by itself over here. All we need to do is square root everything. Or square root both sides, is what I should say. And we get c equals the square root of a squared plus b squared. All we had to do was square root both sides. So the second one says solve for a in terms of b plus c, or b and c. So the first thing we need to do this is we need to subtract b from both sides to get a by itself. So when you subtract b, you're going to end up with a squared equals c squared minus b squared. Then, similar to what we did here, we square root both sides, and you get a is the square root of c squared minus b squared. Sorry about that. And that's how you solve for the different variables. If you were to solve for b, you would simply have subtracted a from both sides instead of b from both sides, and you would get b equals the square root of c squared minus a squared. So this is useful for if we don't know a, but we knew c and b. Or if we didn't know b, but we knew c and a. So that's why we do these solving in terms of other variables within a formula, so that we can determine the one that we don't know if we know the others. So let's look at this one. Here we've got our perimeter. P equals 2L plus 2W, and we're going to solve for L in terms of P and W. So for this, we simply subtract 2W from both sides, and we get P minus 2W equals 2L. And then to get L by itself, we divide both sides by 2, and we get L equals P minus 2W over 2. So this tells us the length if we know the perimeter and if we know the width. Similarly, if we would have solved for W, instead of subtracting 2W from both sides, we would have subtracted 2L from both sides, and you would have ended up with W equals P minus 2L over 2. So let's look at our interest formula here. I equals PRT, and we're going to solve for T in terms of I, P, and R. So when we do this, since this is going to be a little bit more complicated, let me go ahead and write all of this out. Let me restart that. So now let's look at our interest formula. Here we're going to solve for T in terms of I, P, and R. So we have I equals PRT, and we want T by itself. So all we do is we divide out P and R from both sides. And this gives us T equals I over PR. Now, this would end up giving you the same, you do the same process depending on what variable you're trying to solve for. If you wanted to solve for P instead of T, you would have divided out T and R instead of P and R. Similarly, if you wanted to get R, you would have divided out P and T and left the R alone. What this would come up to be would be that P would be I over RT, and R would be I over PT. Once again, you get these, all three, using the same overall process. So let's look at this one, x equals VT, and we're going to solve for V. To simply do this, we divide both sides by T. And we get V equals x over T. Similarly, if we were to have solved for time instead of velocity, we would have gotten T equals x over V. And all we do is we use the exact same technique. We divide out the variable that we're not solving for. So when you're solving for a variable, you just want that variable alone. So now let's look at S equals 4 pi r squared, and we're going to solve for r. And to do this, we just simply divide out 4 pi from both sides. And this gives us r squared equals S over 4 pi. Now we're trying to get r, not r squared. So the next thing we're going to do is square root both sides. So when we do that, we get r equals the square root of S over 4 pi. We don't need to put in any number for pi. This is an S, not a 5. And so we end up with just r equals the square root of S over 4 pi. And if we were to know S, we could solve for r. So let's look at 1 over r equals 1 over r1 plus 1 over r2. First, we're going to solve for r, and then we're going to solve for r1. So let's start off by solving for r. The first thing we need to do is get these to have a least common denominator. so that since we're adding fractions, they have to have the least common denominator to be able to be added. So when we do this, we multiply top and bottom of this one by R1 and this one by R2. This gives us 1 over R equals R2 over R1 R2 plus R1 over R1 R2, which simplifies to being R1 plus R2 over R1 R2. So when we solve for R, we have 1 over R equals this. What we're going to do is we're going to do something rather, it's going to look weird when we do it, but it actually makes a lot of sense. What we're going to do is we're simply going to flip both sides. So we're going to go ahead and put the R up top and then flip these two, and we end up with R equals R1 R2 over R1 plus R2. And that's us solving for R. Now, let's go ahead and look at the second part of that. It says to solve for R1. So what we're going to do is first we're going to get R1 on one side of the equation. So we're going to have 1 over R minus 1 over R2 equals 1 over R1. All we did was we took this original equation, ignoring these bits, and we just subtracted 1 over R2 from both sides to get 1 over R1 by itself. Now we use the same technique. We're going to go ahead and make these have the least common denominator. So this will end up being multiplied by R2 over R2. This will get multiplied by R over R. When we do that, we get R2 over R times R2 minus R over R times R2 equals 1 over R1. This comes out to be R2 minus R over R times R2 equals 1 over R1. Then we're going to do what we did up here and flip and get that R1 equals R times R2 over R2 minus R1. You would use the same technique that we used here to solve for R1 to solve for R2. So let's go ahead and look at our next formula. We have F equals 9 over 5C plus 32. Here we're going to solve for C. So the first step is to subtract 32 from both sides. And we get F minus 32 equals 9 over 5C. So then we're going to go ahead and multiply both sides by 5. And so when we do that, we get 5 times F minus 32 equals 9C. Then we divide out this 9 here, and we get F equals, or 9 over 5 times F minus 32 equals C. Now you can distribute this 5 over 9 if you really want to, but that's not completely necessary. You can simply solve what's in the parentheses and then multiply by 5 over 9. However, if you did go ahead and do that, you'd get a kind of an awkward number. So I would recommend leaving it like this so you don't have to worry about weird decimals or fractions or anything like that. And this is just fine how it is. So let's look at our last formula. So our last formula is going to be this. ax plus by equals c, and we're going to solve for y. So the first step is to subtract ax from both sides. And when you do this, we're going to get by equals negative ax plus c. Then you're going to divide both sides by b. What this gives you is y equals negative ax plus c over b. Now, one of the things that's really useful about doing this is if we separate these into two separate fractions, we'll get something that looks like this. Y equals negative a over b x plus c over b. This is actually something that we are familiar with. This is the same thing as y equals mx plus b. And what this tells us is that we can actually associate specific things together. So that means that if you were given a problem in this form, you could find the slope and the y-intercept and graph it. So suppose you were given a problem that looked like 3x plus 4y equals 12, and you were told to find the slope and the intercept. Or maybe you're told to rewrite it in the y equals mx plus b form. Well, if we look at what we have here, m is negative a over b. So a is 3 because of here, b is 4, c is 12. So we simply go off of this. M is negative a over b. M equals negative a over b, which is going to be negative 3 over 4. And our y-intercept is going to be c over b, which is 12 over 4, which equals 3. That means that if we rewrite this equation, it would be written as y equals negative 3 over 4 x plus 3. So that's the basics to rewriting formulas. I do hope that this video has helped you learn a little bit about rewriting formulas to solve for specific variables and some of their applications. I hope you enjoyed the video, and I'll see you in the next. Goodbye.